In this video, I'm going to discuss how to generate and test indirect and total effects using the AMOS program. We're going to focus on path analysis with measured variables, but the same concepts will generalize in terms of path analysis with latent variables. Path analysis, both with and without latent variables, can include several types of effects that can be of interest to the researcher. There's what's called the direct effect, which is basically the effect of one variable on another, and it's indicated by the single-headed arrow. So for instance, the path from x to y in this particular model, which is designated with the letter A, is a direct effect of x on y. Similarly, the path from y to z is a direct effect, and that's path B. The same would go down here. A and B are both reflecting direct effects. The first one reflecting the effect of x on y, the second one reflecting the effect of y on z. We also have another direct effect, which is, I just have a little C star right here, but basically it reflects the direct effect of x on z. So a single-headed arrow reflects a direct effect in a path model. Now another type of effect is referred to as an indirect effect, and in this case we are looking at the issue of mediation. And when we're talking about mediation, we're talking about the idea that the variation in one variable or the effect of one variable on another variable is transmitted through another variable, a third variable or an intervening variable. So in this case right here, the indirect effect or the mediated effect of x on z flows through variable y, and this is a mediating variable. So the indirect effect is calculated by taking the path coefficient for A and multiplying it by the path coefficient for B. So, in this case, the effect of x on z, again, is flowing through y. The second model, model 2 down here, we have the indirect effect of x on z flowing again through y, or at least partially through y, where we have path A and path B. So again, path A multiplied by path B would constitute the indirect effect of x on z. So in both of these models right here, the indirect effect of x on z is calculated as path A coefficient times path B coefficient. Now, an indirect effect can partially or fully explain the relationship between two variables. And note, when I talk about explain, I mean it in terms of the proposed causal association. So in Model 1, we can see that the effect of x on z is full. In other words, or the indirect effect is full. Because basically there's no other relationship between x and z. All of the causal influence of x on z flows through variable y. So in this case right here, y would be, which is the mediating variable, is proposed to fully explain the relationship between x and z. Now in Model 2, we have a partial mediation model. And in this case right here, the effect of x on z flows in part through y, which is our proposed mediator. So again, the indirect effect is calculated as path A times path B coefficients. But we also have what's called a direct effect between x and z. In this case, there is no proposed mediation here, but part of the influence of x on z is direct. A lot of times this just sort of reflects the idea that we don't have any other proposed mediators. In that case, the only other option in terms of specifying the relationship between x and z is direct, whereas in this part of the model, we have a proposed intervening variable or mediating variable. And so the effect of x on z is partial through the indirect effect and then partially direct. So the total effect of one variable on another is basically equal to the sum of all indirect effects and direct effects within a model. So for Model 1, the total effect of x on z is basically equal to the indirect of x on z, which is taking path coefficient A and multiplying it by path coefficient B. In Model 2, we have both an indirect effect of x on z, through the mediator y, and we also have a direct effect of x on z, which is the c star path. So to calculate the total effect of x on z, we simply take the product of a and b, which is the indirect effect, and sum or add it to the direct effect, which is path c that we see right here. So in path analysis in AMOS, basically here's an example of a model, and basically we are modeling both direct and indirect effects. So the effect in this particular model of performance goals on achievement is completely indirect, as we have one arrow going to anxiety, another arrow going to from anxiety, the mediator, to achievement. And so as you can see, there's no direct path that flows from performance goals to achievement. So the effect of performance goals on achievement is only indirect. This, with respect to the mastery and interest variables, we have mastery exhibiting a direct effect on anxiety, and obviously anxiety to achievement is a direct effect. But basically part of the effect of mastery on achievement is indirect. That is, we take this path coefficient right here and multiply it by this path coefficient here, and that would give us the indirect effect that you in this particular model. But we also have the direct effect of mastery on achieve as well. So in other words, we're specifying a partial mediation with respect to the relationship between mastery and achievement. Part of the effect is direct, part of the effect is indirect. With, again, going back to performance goals, the proposed relationship between that variable and achievement is completely indirect through anxiety. Similar to the mastery predictor variable, we also have interest, which is proposed to exhibit a direct effect on achieve, but then also an indirect effect through the anxiety mediating variable. So to run our analysis, we will go into analysis properties, and we have to essentially lay out direct, indirect, and total effects. So if we go under analysis properties, in this particular video, this is based on a complete set of data. So there's no missing values on any of our variables, and so we would not be clicking this intercept, estimate means and intercepts box. If we did have missing data, then we would want to click this. So to ask for the direct, indirect, and total effects, we'll go to output, and under this box right here, I've already asked for standardized estimates, squared multiple correlations, test for normality and outliers, but then here's the box, indirect, direct, and total effects. So basically, to illustrate this in action, I'll just go ahead and run this analysis. So here we are under analysis properties. I'm going to ask for output, and I'm going to ask for indirect, direct, and total effects. Okay, so so that's what I need right there. So I'm going to click off of that, go ahead and really quickly save, and click on calculate estimates. And basically there was a little error. I had to re-upload the data into the file, so we've done that. So now I'm going to go ahead and click, and so when I go to my little output box right here, I will click on estimates. And so basically all of the direct effects that we had in the model, so I can actually click over here and just kind of show you, these are the unstandardized estimates. These path coefficients are all reflecting the direct effects in the model. So if I want to look at the tests of the direct effects in the model, I can look at the unstandardized regression weights. That's what these are right here. So you can see here the values are rounded to 2 decimal places. In the output here, it's rounded to 3. But basically, you can see that we have the regression weight here, standard error, and then the critical ratio is basically formed as a ratio of the estimate divided by the standard error. And typically we would, given that SEM tends to be a large sample procedure, we compare this against Z values in the Z table. So the p-value, or the probability value, indicates whether or not we have statistical significance. So you can see in this particular model, we got performance goal, to anxiety, that path here is 0, but basically it's 0.004. It's not actually 0. But you can see that path is not statistically significant at the 0.05 level. When we see mastery to anxiety, you can see it's negative 0.4. So in other words, higher scores on this variable are associated with lower scores on anxiety. The estimate here, you can see it was rounded off right here. And so we end up with negative 0.398, and the 3 asterisk here is basically is considered a p-value less than 0.001. So that path was statistically significant. Then in terms of mastery to achieve, this direct effect right here, which you see right here, is statistically significant. Higher scores on mastery goals are associated with higher scores on achievement. And then we have interest to achievement as well. This path was positive and statistically significant. If we want to look at the standardized estimates for those paths, we can just click on that if we want. If we want to look at it in terms of our output here, you can see these are the standardized weights. Basically, these would be the beta coefficients in the context of a standard regression analysis. So the nice thing about beta weights is that we can form comparative judgments about which effects in the model are larger versus smaller. So you can see that the path from, and so we interpret the size or the magnitude of the effects in terms of their absolute value. So you can see mastery has a negative predictive relationship with anxiety. It has a positive relationship with achievement. The larger effect would be this one right here, with mastery running to achievement, with the beta coefficient of 0.38. Whereas the next largest effect is this one, where mastery is running to anxiety, beta coefficient of negative 0.34. The next largest effect runs from interest to achievement with a beta coefficient of 0.29. So that's basically how we can use that. We can't use the unstandardized weights, or the regression coefficient, excuse me, in order to judge relative size of effects, because these are in the original units of measurement for our variables. But the standardized regression weights, we can use these, because essentially this is after we've converted all of our variables to have a mean of 0 and standard deviation of 1. So given we have the same scale of measurement, we can make comparative judgments here that we can't make when we're looking up here at the unstandardized coefficients. So if we go down a little bit further, you can get down to matrices, total effects. So these are unstandardized total effects, standardized total effects, unstandardized direct effects, standardized direct effects, unstandardized indirect effects, and standardized indirect effects. I could also get there by clicking on this little button right here and clicking on matrices, and it will take me, to whatever I want to look at. You can go either way. So for our purposes, for our analysis, let's say I want to look at the indirect effect of let's say, mastery on achieve. So in this case, we have the path. So I'm going to go to my unstandardized just for the time being. And in this particular case, if I take this path coefficient here, negative 0.4, and multiply it times negative 0.04, then the indirect effect of mastery on achieve down here, this is the unstandardized, would be 0.016. And so basically, as you can see, that's the value. If I want to look at the indirect effect of interest on achieve, I would take this path right here, 0.01, and multiply it times negative 0.04, and you'll see that it comes out at negative 0.001. If I do the same in terms of the standardized coefficients, you can see that basically in this case I would be looking at these coefficients down here. So mastery to achieve, basically if I take mastery negative 0.34 multiplied times negative 0.05, I would end up with 0.018, and the other one here of interest to achieve 0.01 times negative 0.05, and I would end up with approximately negative 0.001. You can see performance goals to achieve as well. It'd be 0.04 times negative 0.05, and that would get me the negative 0.002. These are actually very small effects. In terms of making judgments about the size of the effects or the relative size of the effects, then you would probably want to look at the standardized indirect effects in terms of making comparative judgments about which indirect effects were larger relative to others. So in this particular model, the indirect effect of mastery on achievement is the largest, followed by the performance goal on achievement, followed by interest on achievement. You'll notice that anxiety, it says anxiety to achievement right here is 0. There is no indirect effect. That's why why that value in here is 0. So whenever there's no indirect effects, then all the other values would end up being 0. When you have interest to anxiety in this particular model, you can see obviously there's no indirect effect. It's only a direct effect. And so there's 0 here, and the same would go for the other predictors in relation to anxiety. The direct effects that you see right here, the unstandardized and the standardized indirect effects, those values are going to basically equal the unstandardized and standardized regression coefficients that you see in this particular table. So it's not particularly useful to look at the direct effects in this particular table. You can, but it's just going to tell you the same thing as what we saw up above. If you want to talk about the total effects, there's the total the unstandardized total effects, and then we have the standardized total effects that you see right here. So now let's say I want to modify things, and let's say I want to look at let's say I include another mediator. Let's make interest a mediator, both interest and anxiety mediators between let's say mastery and achieve. So I've got mastery predicting anxiety, mastery predicting interest, and both of these are influencing achievement in this particular model. So really quickly, I'll draw this out. I'll just pull up that particular model that we see right here, and in this particular case, there it is. So I'm going to now run the analysis, and I'd actually performed a bootstrap on this. I'm going to undo this for right now, and I'll show you this in a second. So again, I'm going to click on indirect, direct, and total effects, run the analysis, and so when I look at my output for estimates, I can either scroll down all the way, or I can just double click here, and I get my matrices. I got my different effects that I was just telling you about. So basically, as we're looking at the indirect effects, again, here are the unstandardized values in this particular figure right here. And so the unstandardized indirect effect of mastery on achievement, in this particular case, it's important to note that this basically is taking mastery to achievement, and it's summing up two routes. So it's basically taking this coefficient here, multiplying it by this coefficient here, and then it's taking this coefficient here and multiplying it by this here, and then summing those two indirect effects together to give you basically a total indirect effect. So the total indirect effect of mastery on achievement is 0.178, the unstandardized indirect effect. So keep in mind that this value right here is not breaking it out into each individual route from mastery to achievement, but rather it's taking the total indirect effect with respect to both of these mediators that you see in this particular model. In some programs, you're able to isolate the indirect effect in terms of individual or trace particular paths and talking about those effects individually. But in this particular case, in AMOS, you're not really able to do that. But you are still able to talk about the indirect effect of mastery on achievement just by taking the sum of both of these, the products for these two paths here and these two paths right here. So that's just something that I think it's important that you keep in mind when you are running your analysis. So if I want to look at the standardized indirect effect for mastery goals, again, I would be taking the product of these two paths and summing it to the product of these two paths right here. And so indirect effect, the standardized indirect effect would be 0.196 with respect to mastery and achievement. Remember that basically in this particular case, the total effect, whether we're talking about the unstandardized total effect or the standardized, is basically reflecting then three effects in sum. There are two indirect effects: mastery to achievement via anxiety, mastery to achievement via interest, and then also a direct effect that you see right here. So basically, if we sum this direct effect plus the total effect of the total indirect effect, we end up with the total effects that you see in this matrix and this matrix. Now, one last thing I want to mention is, perhaps you want to determine if any of the indirect or total effects are statistically significant. Can you do this? Well, yes, you can. Right now, if you just look at the values that are printed out in the table, all you're really able to do is to sort of identify the values, and then with the standardized, either standardized total effects or the standardized indirect effects or the standardized direct effects for that matter, you can make comparative judgments about these effects at this level. But if you want to determine statistical significance with respect to one of these effects, then you can do this through the use of bootstrapping in AMOS. So to do that, we will click on Analysis Properties and go to Bootstrap, and that's where you run the bootstraps. Basically, bootstrapping involves treating your sample data as sort of a pseudo population, and you draw random samples with replacement from your sample data, because you're essentially trying to simulate data that would come from a given population. You draw random samples of the same sample size as your original sample, and then essentially compute your estimates and generate sort of a sampling distribution for your standard errors. That's basically how it works. So to do this in AMOS, first of all, one thing to note is that this button cannot be clicked. So in other words, if you have any missing data whatsoever in your analysis, then you're going to have to deal with the missing data problem first by completing a complete data set, or generating a complete data set. And this cannot be clicked, otherwise it's not going to work. So if I click this right now, even and let's say I want to ask for bootstrap results for if I click on calculate estimates, it actually did work. But generally speaking, uh, actually, it will still run if you click on estimate means and intercepts. But if you have missing data, you have to click on this. And then if you have that missing data at all in your data set, then it's not going to generate the bootstrap results. So that's just kind of FYI. But I actually had no missing data in this data set, so I'm just going to leave this unclicked. But basically, you have to have a complete data set. That means that there can be no missing values on any of your variables in your analysis. If there are missing values, then that forces you to click this. Otherwise, you'll get a nice little error message. And then if you try to run the bootstrap, it's just not going to work. So just kind of keep that in mind. But given that I don't have any missing data in my current data set, I'm going to leave this clicked off, which will allow me to generate my bootstrap samples and generate the standard errors and the test results that I need in order to test the indirect effects for statistical significance. Just kind of as a side note, if you do have missing data and you need to generate a complete data set, there are various ways that you could do that. One way is through a deletion method like listwise deletion, in which case if you have missing data on any variables in your data set, you delete those cases that have missing data on at least one of those variables. The downside of this approach is that it reduces your effective sample size, and potentially if there is some systematic reason why there's missing data, then you can end up skewing or biasing your sample, your results. Another option is some type of imputation method, such as regression imputation or stochastic regression imputation or Bayesian imputation. These are some of the options that are available in AMOS. I'm not really going to go into that for this particular review, but just to say that there are some options there to create a complete data set that you can then feed into AMOS and then run the analysis and generate the bootstrap results. So at any rate, under Bootstrap, I'm going to click on Perform Bootstrap. So typically it's, the default, it looks like this. The defaults in here are actually 200 here for number of Bootstrap samples and 90 here for 90% confidence intervals. But I actually clicked this before and changed the values to 500 and 95 so that I get 500 Bootstrap samples and 95% bias corrected confidence interval. So now I'm going to click on OK, and I'm just going to go ahead and resave my little file here and generate and click on Calculate Estimates. So basically, in this particular case, when I look at my output, I click on Estimates, and again, if I double click here, click on Matrices, I've got all of my different types of effects. So basically, if I click on, let's say I want to look at the indirect effects. If I click on this right here, then down here, this little estimates bootstrap section highlights. So right now, these are the estimates for the unstandardized indirect effect of mastery on achievement is 0.178. If I want to test this for statistical significance, then I can click on bootstrap confidence. And so in this case right here, I've got a 95% confidence interval for the relationship between mastery and achievement for the indirect effect or the unstandardized indirect effect. So basically, the lower bounds of that interval is 0.074. The upper bound is 0.312. And so basically, if the null hypothesis for the indirect effect is that it is equal to 0. So if 0 falls between the lower bound and the upper bound value, then the null hypothesis would be retained, in which case we would say that the indirect effect is not statistically significant. In this case, 0 falls outside of these two bounds right here, so then we would infer that the indirect effect of mastery on achievement is statistically significant. So if we want to look at this a little bit more in depth, this is basically the 95% confidence interval for the unstandardized indirect effect of mastery on achievement. And like I said, 0 falls outside that interval, so we would reject the null. We could also look at, if we want to look at a p-value, then down here you've got p-values for a two-tailed test of significance. And so the p-value for the indirect effect of mastery on achievement is 0.002. So if we adopt a conventional 0.05 level for the test of the indirect effect, we can say that the indirect effect was statistically significant for the model. Notice too that we can look at things in similar way with the standardized indirect effect. So we have the confidence interval for the standardized indirect effect ranges from 0.076 to 0.338, and so obviously 0 is falling outside that bounds, so we would reject the null there. Or if you want to look at the p-value down here, you can look at that and determine the standardized indirect effect is statistically significant. Also, I do want to note that we also have other options with respect to the regression weights that we saw up above, that the bootstrap results don't only pertain to the indirect, direct, and total effects, but, well, we have the direct effects right here, but we can also look at, if we wanted to test these unstandardized effects using the bootstrap method, well, there it is. You actually have confidence intervals that are formed for the bootstrapped direct effects in the model, and then the p-values associated with that. So you might use this option if there's some kind of question whether or not you have, say, for instance, violations of multivariate normality, and maybe you don't necessarily trust the normal theory estimates and tests that you have right here, and you want to adjust for that, then bootstrapping can be kind of helpful in those cases. But at any rate, that kind of sums up or provides an overview of looking at the different effects in the context of a path analysis using either observed variables or latent variables.